Hey, welcome back to the bench. Good to see you again. Thanks for joining the channel. Today I have some amplifier goodness sitting on my bench, and I think we're going to get deep into this one. This is kind of a score, I think. I don't know. Tell me what you think. It's a JVC A-X7 stereo integrated amplifier with Super A. Whatever Super A is, it's some kind of a branding or marketing gimmicky thing there, so I don't know what that is, but it's a nicely, looks like it's nicely designed amplifier. It's got a lot of nice features, and it's got some size and weight to it, so it's, you know, it's going to have some power. And I looked it up. I think it's 90 watts a channel, so all good that way. But it's got kind of a unique styling to it. It's got this huge knob and these long, skinny, tall buttons on the front. Now, typically there's a door that covers all these, and you flip it down and you access all the controls in here, and then you flip it up and you can't see them. There's some indicator lamps here that tells you what mode you're in. Speaker 1, speaker 2, subsonic, tone, moving magnet, moving coil. And then there's indicator lights here for power, muting, tape monitor, auxiliary, tuner, phono. And yeah, it says pure negative feedback. I wonder what that means. Anyways, let's have a look at this. Yeah, that's what I paid. Okay, so starting at the left here, we have a big power button, and I assume it's illuminated because it has like a plastic insert in there. Same with the muting. So we have two sets of speakers. We have subsonic filter, and then we have a switch for turning the tone controls off. We have bass, treble, and they have a nice feel to them. They're also marked with graduations on here. It says plus 10, 8, 6, 4, 2, 0, and then it goes 2, 4, 6, 8, 10 the other way. We have an input here for a tape monitor 2. Record and playback left and right. It's unusual to put it on the front like that, especially behind a hidden door. Okay. We have a muting button, and we have a huge master volume that is marked off in decibels. So what do I got? You can't see it here. I'll show you. You can see this marked in decibels. It says minus 80. Actually, it's infinity there. And then minus 80, 70, 65, and goes all the way up to 20, 18, 16, 14. Then we're starting to get loud. 8, 6, 4, 2, 1, 0, and that's maximum volume. So it's kind of unusual to see a volume knob marked in that way. So on this side we have balance control left and right, and it's also graduated and marked. It's marked center. It's got a little detent there. Loudness button, mode stereo, mono. And then we have tape dubbing switches. We have dubbing from source, 2 to 1 or 1 to 2. And this is your tape monitor. 2 from the front or 2 from the back. So that's your second tape monitor. You can select from the front inputs or the back inputs with this switch. And then this switch here selects tape monitor 1 or 2. Here's your tape monitor button up here. So this is your master. When you press that in, you're going to either get tape deck 1 or 2, depending on which way this switch is, and then you're going to get front or back inputs depending on which way this switch is. So there's a lot of control, a lot of different things. You can hook 3 tape decks up to this thing and use all these switches as ways to communicate between them. Phono 1 and 2. So we have 2 phonos inputs with the master switch here, and here you can select phono 1 or 2. Obviously on the back there's 2 inputs, and here we can select moving magnet or moving coil, which is a nice feature. So it's well optioned out and a lot of versatile inputs. Alright, so here's our inputs on the back. We have 2 phono inputs, phono 1, phono 2, and they're all gold plated, which is nice. Tuner input, an auxiliary input. Here's our first tape loop, record and play, and then our second tape loop, tape 2, record and play, and then it has DIN connector for tape 1. What is CEA? I don't understand what CEA is. I'm sure somebody will tell me. 2 output speakers, and they are saying 1 and 2, 1 plus 2, 16 ohms minimum, or 1 and 2, 1 or 2 is 8 to 16 ohms. So they're not recommending 4 ohms on this amplifier. That's unusual. It's a high power amp. I think they'd put 4 ohms on here. On this side we have a master power fuse. It's a 6 amp, 125 volt. And we have 33 courtesy outlets. 2 switched, 1 unswitched. Nameplate, and we have behind this plate we have a voltage selector. So this is a world. Let me see. You can probably open this up and show you. Probably good for anywhere in the world. So we got 120 volts. It's set for that already. 110, 220, or 240, depending on how that switch is set. So it is quite dirty. It's got like a film of, you know, just regular dirt, I guess. Some coffee stain here and some residue from stickers. And yeah, it's quite dirty. You can see on the knob there's some kind of unknown substance. But let's have a look inside. Now, full disclosure, I did have the cover off and I blew the dust out of it because it was quite dusty inside. So here's a look at the top. It's actually not bad inside. I don't think it's seen a lot of smoking, but that could be wrong. Alright, here we go. So we got a big huge power transformer here. It's a toroidal power transformer, and it's got voltages and currents listed on here. Victor Company of Japan Limited, Tokyo. This board back here is all AC input and voltage selection. There's the courtesy outlets on here. There's the switch for the voltage selector. So all that stuff's on the back corner here. And it's all exposed too, so you gotta be careful. This is all exposed wiring. And then we have our power switch. A big chunk power switch on the front with a little bit of exposure there too. Power supply back here. This is all power supply and audio amplifier. It's all incorporated on the one board. Can't really see it. Back here it's power amplifier and power supply. We got 63 volt, 6800 microfarad caps. They're branded JVC caps, but I think it says high density capacitors. Output board. Here's our input board, but it's shielded with a cover. Power amplifier here, the driver transistors and everything's under here. I'll swing that around and we'll show you. This board here, down here, looks like tone amplifier, tone board. It has the bass and treble controls, some heat sinking going on. I wonder what they're doing with all this heat sinking on the tone board. Looks like they put a lot of engineering into this thing. So this board down here looks like phono stage. There's a lot going on here. You have some dual FETs, the 2SK 1146, or sorry, 146. Looks like it's all phono stage down here. Look at these massive caps, film caps. Those are 4.7 microfarad film caps, and some power going on here. Here's a better look at the power amplifiers. You have the Super A. Looks like a little chip or module. Looks like it's wrapped in aluminum. There's one here and one here. Don't know what they're doing with that. And looks like it's really well built. Kind of curious on when this thing was manufactured. It's hard to say. I have to get some date codes off of something here. Here we got a lot of switching going on. This is our function switches. 4 function switches, tape monitor, And below that is some more switching going on. You can't see it. Massive volume control. Kind of curious on what's going on in here. So I'm going to flip this over. I think it has a removable bottom, or partially removable. Alright, so it has a half bottom removable plate. Exposes these two cards, these two circuit boards. This one here looks pretty good condition. There's not much going on here with as far as heat buildup or crack solders. Everything looks fine with this one. This one here on the bottom, this is a different story. Got a lot of heat zone right here. And I was looking on the other side, and we have a lot of cracked transistor leads and stuff like that. They're all cracking because of the heat. This is all power supply down here. Some fusing. And we have relay, speakers relay down here. And then we have power supply here. This looks like the regulators. And lots of black stuff oozed out on the board. You can see there's a kind of in the shadow here, but this board is all stained with black. Right there's a big spot. So the glue is an enemy here as well. These caps look like they're cooked, and I tested a few of these caps around on the power supply here, and they're all cooked. Very high ESR open, so you know what's going to happen there. We're going to put new caps in this thing, so might as well get started. Doesn't look too hard to work on. Looks pretty easy, except for the power amplifier has to be removed from the chassis, which shouldn't be too much of a trouble. So I'll get started on recapping. A lot of these caps look like they're cooked. A lot of heat down here too. So, but I'm kind of curious if this thing works even. So let's maybe plug it in and try it out and see if these two fuses are even any good. Just 2 half-amp fuses. Both good. Okay, and the main power fuse in the back is also good. So let's hook it up and plug it in. Here's the back side of that board where that heat zone is, and you can see there's cracks on some of these transistors. This one here, cracked. Looks like cracked. A few of them are down here. Yeah, this is probably causing the owner a lot of grief when they hear these crackling pop noises in the speakers. This is what's going on here with these cracks. This is in the power supply too, so it wreaks havoc with everything in the amplifier. Alright, speakers are connected, and I have a source connected. Let's turn this thing on. The lights flashed and then went out. Drawing 23 watts. I heard a click. That's the left channel. We're on phono. Right channel silent. Right channel silent. Okay, we got amplifier noise out of the left channel. We're on phono right now, so let's go to tuner. Silent. Auxiliary. We got both left and right, but there sounds like there's a distortion. Or there was a distortion, now it's gone. Left, right. It doesn't sound like I have. Okay. Muting. Tape monitor. Yeah, none of these lights are on. Looks like we have a problem with the power. It is working though. It is working somewhat. So overall it is working, and it seems to be working okay. I didn't measure anything. I have a feeling it's mostly just dirty pots, dirty switches, and dead caps, and plus a few bad solder joints. So it's going to be this one, kind of uneventful. But let's get started. I'll get started on the capacitors, and I'll start with these two boards, and we'll take it from there. And we'll work on the power amplifier. Maybe we can do that together. There's not very many caps on here. There's just maybe 2 on each channel, and then the main filters. But everything seems okay with the power amplifier. It's mostly power supply and control amplifier here is going to have needs the most help. So let's get started on that, I guess. All right, here's the amplifier board. Doesn't seem to be a lot going on here. There is these clusters of transistors. These are drivers. These two here are drivers, and then there's pre-drivers. And it looks like they have only part of the amplifier circuitry on this board. They have the drivers, the main outputs, and the input section, it looks like it resides on another board. These Super A chips here, there's one here, Super A, and then there's another one in the other channel. These don't appear to be anything to do with signal processing or amplification. I looked at the schematic. It looks like they appear that they are for bias stabilization and temperature stabilization, and they work in conjunction with this transistor that's bolted to the heatsink here in this channel and this channel here. So, not much going on. I replaced 4 caps on this side. That's all there is. I removed the main filter caps and tested them. These come back at around 6,000 microfarad. There's a couple that are down to about, there's one that's down to 5,800, and the rest are up around 59, 6,000. And an ESR of about 32 milliohms. So I'm going to put these back in. These are still good, and we're going to run with them. They were glued down with this nasty glue. It turned all the board black wherever it contacted, so I scraped that all off and cleaned it. Checked the back side for solders. Everything looks good on this board. Yeah, like I said, there's not much going on here. This little chip here, this is circuit protection, or not, no, this is the speaker protector circuit, speaker protector. And its job is to monitor the output and switch the relay off when it senses something wrong. And that's all in this little circuit here. This side here, there is this point and this point. This is where the power transformer winding comes in, and then it's rectified and filtered. Looks like for whatever reason JVC had provisions for putting fuses here. You could move the wires back to here and here. You could put fuse holders in, and you could add fuses if you wanted the extra protection. But for whatever reason JVC thought it wasn't necessary and deleted this. So that's something for you to ponder on. I also added some filtration to the bridge. I don't know if you can see here, but there's some MLCCs that I added. These are 680 nanofarad at 100 volt. So that's just to knock down any transients on the bridge rectifiers. And they also have here provision for caps here and here across the positive and negative rails. And if you wanted, you could add capacitors here too, like 100 nanofarad or 220 nanofarad. Something that'll reduce transients. Other than that, everything's good. I'm going to solder the caps back in, and this board will be done. Put back in. Alright, so I removed this relay, and it's all relays are suspect in my opinion. If you have a piece of equipment with a relay, yeah, it's question whether it's working good or not. So I'm going to test it right now. Let's see, I don't have 2 cameras hooked up, but I got 1 at least. So these are the contacts for one side, and then I have 24 volts on my power supply here. If I turn the power supply on, it works better. There we go. Okay, 23.2. I'm getting 600 milliohms. Let's see, I'll show you. I might have to turn this music down because it is probably something that's not. Okay, so here we go. Power on. Well, 2 ohms. 2 ohms. 40, 400. 1 ohm. 1 ohm. Yeah, this needs cleaning because we're not getting consistent and it's way too high. Let's try the other side. Connect this around. Here we go. Okay. What happened here? Oh, it's got a built-in diode, I guess. Okay, there's 600 ohms. Wow. It's terrible. 65 ohms. Yeah, this relay is really baked. It needs good cleaning on the contacts. Look at how bad that is on that one side. It just goes up and down and all around. Okay, I think I've seen enough. Alright, let's open this. Don't know. This is an odd, it has an odd pin arrangement and odd design to it. It's got a contact here and one here, coil in the center. These 2 pins are coil in the middle, and then this is one set of contacts and the other. So it's kind of a really difficult one to replace. If you needed to replace it, you need to get just the right model. Or you'd have to just sub it in and wire it to the board. Let me put this one here. Let's see, come on. Put this under here. And then, oops. Screwdrivers. Okay, let's try this again. See if I can get this one. There we go. Okay, now we have our contacts. Looks like they have one big button on the bottom here, and then there's 2 small buttons on top. And how do we clean this? I don't know. I might have to take this apart somehow. I don't think it's possible. Okay, we're going to have to get in there and clean that somehow. So I don't know. I don't think polish is going to work because I won't be able to clean it out after. Oh boy. This side is really bad. Okay, let me think about this. Might have to get some kind of paper in there and clean it out. Okay, what I'm going to do is just get paper and fold it like so, and then spray it down, put it in the contacts here, and spray it down. I'm just going to use 40, what is this? 409B. This is 0 residue. I'll get this paper soaking wet, and then we'll close the contacts. Get a polishing action going. Not much is coming out. Let's do the other side. Get some more on this. Ooh. Okay. Get this side cleaned. Let's see how well this operates now. Alright, so let's test one side here. Still getting 7 ohms, 8 ohms. That's no good. We're going to have to do something better here. I think, let's give it repeated treatments. I really don't want to do polishing if I don't have to, but we can. You're still pulling dirt off. Let's try one more time.
Mr. Speaker, I was as of the third testimony when that was brought to light, but until then I was not aware of it.
Ooh. Okay, we're at 500 milliohms now. We're getting better. Might have to get, what I might have to do is use this paper, put a little bit of polish on there and use that as a, I don't know, I really don't want to use sandpaper.
Mr. Speaker, I've met Paul Gerard at
These contacts look like they're gold plated, which is kind of the wrong material to be using for this application. So let me do some repeated cleanings and I'll come back. Okay, so this worked. I used Silvo and I applied a little application of Silvo on one side of this piece of paper and then the other side, and I use that as a polishing tool in the contacts like this. And then I took another part of the paper and I soaked it in alcohol and I used that as a cleaner to follow up with the polish. And it looks like I got most of it out. I can still pick at it and get the, probably what I'll do is I'll blow this out with compressed air, because once the polish dries it turns into like a cake powder. So now that this has been cleaned and polished, let's test this. So let's put this on this side here. Okay, now let's test this out. Here's one side, got 23 milliohms, which is a hell of an improvement. And then the other side is 19, 17 milliohms. So success, yes. So I'm going to try and get in here and clean out any of the residue that was left behind, and then we'll get this soldered back in. Alright, so I got it all back together, and I let's do an initial power up. And here we go. Turning it on. Jumps up to about 75 watts, drops back down to 22, relay clicked in, and we still have no illumination out of any of these lamps. Now I checked, one lamp here is missing and the other 3 are burned out, okay? So that's not the problem. There's a lamp here that's not burned out, and this one, these don't work. These lamps are not working. These LEDs are not working. This lamp's not working. This one's burned out as well. So I think I need to dive into this. Let's look at this power supply. Okay, so we have these 3 wires here are for the lamps, and right here it says on the board LED drive. So I'm assuming this transistor here, this is a series pass transistor, has something to do with this little supply for the lamps. So let's see what we got here. I'm going to turn this on. And I'm going to check these wires for any voltage. And we got nothing. Nothing there at all. So let's try this transistor. Okay, got 67 volts there. 68 volts there. 68.5. 68.4. 68.4. I've had this transistor out and it tests fine. but it looks like it's got an emitter collector short. Let's see here, we got a resistor here, 68. Where else? We got nothing happening here. Yeah, we got a lot of... I'm going to have to look at the circuit here and figure out what's going on because we got no power coming from it. So, let me give me a chance to have a look at the schematic. Okay, I think I'm making progress here. I replaced this lamp that was missing. And I think this is tuner, I'm not sure. But when I replaced that lamp, then other lamps started working. For example, this is the power lamp, or on the volume control. No, this is the muting lamp. That's right, muting. We still have no light and not power. Okay, but when I switch functions, you can see these lamps go out. It's almost like they're in series with each other. So that I got one here, this one, and then when this lamp and this lamp go out, the LED stops working. And I have the LED working right now. And if I play around with the switches, let me see here. I think there is more to be done. Okay. But if I switch functions, all those lamps go out. It's really weird. So I think the solution here is to replace all the burned out lamps and it should all start work again. But what I really wanted to do is get rid of these lamps. Like this power lamp here, for example, is out. So I wanted to replace them all with LEDs, but it doesn't look like it's possible because they have some kind of interconnection. Alright, so I've been doing some mental gymnastics here, trying to figure out this lighting system they have on this A-X7. It appears they're doing some trickery here. They have bulbs in series with each other, and it just doesn't make any sense to me. So I've been experimenting by replacing these bulbs with new ones, these burned out ones, and you obviously have to get the voltage and current correct, otherwise it just won't even light up. One bulb will be so dim you can't see it, and the other one goes bright. So they're doing some trickery here with this circuit. Now they got this here. I'll show you. I don't know if you can see it. All this area here is to do with the lamp drivers. Right here they have like what looks like a multi-vibrator, and it looks like they're using this to flash bulbs with this circuit. It probably does a on off, or a slow blink. And some of these transistors here are drivers. I think this one here, this transistor here, is the TO22 package device that's on a heatsink, and this one is like a current source. I'm not sure. They have this schematic jammed in here. It's like they really screwed up and they ran out of paper, so they jammed the drawing of the circuit in this little space here, and you can't even read part numbers or values because it's all jammed in here. And they did a pretty poor job on this schematic, I must say. So I'm trying to figure out this schematic. They have these LEDs here, and you can see above them they have all these switches, and these switches are to short out the ones that aren't being lit to allow current to pass through the switch instead of the LED. And then the only one that should be lit is open. But if you turn all these switches on, they all light up, so they lighten up in a string. But like I said, it's probably a constant current source they're using, because one LED or 5 LEDs, the brightness is the same for all of them. So they must be doing something to that effect. But I want to get through here and replace all these lamps with LEDs. I might have to just rip this all out and rewire it to work, because the way it is now, it's just a nightmare. Like I said, I'm trying to figure things out and it just hurts my head. I just have to walk away from it. So I'll get on it and I'll try and figure this out, and then I'll get back to you. Okay, I think I finally cracked this nut. So let's see, I put LEDs on these wires. Let's plug it in, try it out. It is starting to come alive slowly. With every bulb I replace, a little bit more of it comes alive. The problem is all these bulbs are independent on each other to be alive and working before they fully work as a system. So I'll turn this on. And let me turn off some lights here so you can see better. I hope you can see better. So turning it on. We've got a power light. This volume control lamp is blinking until it relay clicks. This is the mute. Mute is working. We got phono tuner auxiliary and tape monitor. So it seems like it's all working now. I still have 2 incandescent lamps to replace. I want to put LEDs in their place too, because I just don't think they're gonna survive with time. It's not a very good system. Let me explain to you what I did to get this to work. Okay, let's get ready here. So what I did is I took one of the lamps and I got it working in one of the circuits. And I measured the voltage across the bulb when it was working, and I came up with 7.25 volts. It's probably about an 8 volt nominal, but this is what I measured. So that's a start. So what I did is I took that bulb out of the circuit and I put it on my power supply and I put 7.25 volts on it, and I came back with 50 milliamps. Okay, so we now know our voltage and our current for that bulb. So if you do simple math, R equals E over I. So if you go R equals E, which is 7.25 divided by 0.05, and that comes back at about 144 ohms. Now the closest match to 144 ohms is 150 ohms. So you could essentially take this bulb out and replace it with a 150 ohm resistor, and the circuit would act the same. You'd have the same current flowing through it. You'd have the same voltage drop across it. So knowing that, I wanted to make the load resistor on each of these bulbs 150 ohms. Okay, but then I also want to add an LED here. So we add an LED. Excuse my drawing. I want to put it across this resistor, but we don't know what the dropping resistor needs to be. So for about 5 milliamps, I'm using high brightness LEDs too, so these are going to put out a lot of light, and I usually run them around 5 milliamps. So if we do Ohm's law and we calculate the current through a 150 ohm resistor with 7.25 volts, so we got I equals E over R, so we got 7.25 divided by 150 equals, so we get about 48 milliamps here, and we're getting about 5 milliamps here. Okay, so what do we need for 5 milliamps? Well, we need to figure out this resistor here. So we have 7.25 minus the diode drop, which is, let's say, 2 volts, equals 5.25 volts. So we got a 2 volt drop across the diode, 5.25 volt drop across the resistor. So then we can calculate our value for this. R equals E over I. So we got, let's do this again, 5.25 divided by 0.005 for 5 milliamps, and we come back with 1050 ohms. So our closest standard value is 1000 ohms, and that's exactly what I'm doing here. I got 2 resistors and an LED. I have the 1000 ohm in series with the diode, and I have 150 ohms across both of them, and that pretty much simulates a bulb in this situation with that voltage. So that's what I'm putting on each of these bulbs. I'm cutting the bulb off and I'm putting this little circuit in, and that'll be a suitable replacement for this, and it should last indefinitely. Alright, so now it's time to set the amplifier up, and I have the adjustment procedures here. It's 2 simple steps. Do the center balance adjustment, which sets the 0 point for the outputs, and then the idling current, and there's separate areas for that. We'll get into it. So they say first let the thing warm up for 5 minutes, and then check on the output for DC, and it should be less than 10 millivolts. Let me see if I can get this connected. What do we got? 32 millivolts. Okay, and that is the left channel. So adjustment points are different for the two. I don't know if I mentioned this before, but this amplifier is spread over 2 boards, the power amplifier. So on this board you have the power supply and the driver transistors and the biasing on this board, and the outputs, of course. And then on this board you have all your input section, your differential pairs or long tail pairs, and all of that is on this board here. This is power supply down here, but this is all input section. So the 2 adjustments are right here, and they are R311, center adjust left channel, and R312, center adjust right. So I'm going to go for this one, and let's look at the meter. Let's see if we can get this down to 0. It's very, very touchy. I'm barely turning it. Okay, we got it down below 10. Let me give it a little more. Give it a little tap, tap, tap. See if I can get it down to 0. Very touchy. Now it's went the other way. Let me try cleaning this pot by doing some of that. Okay. Still drifty. So we're down to around 1.2, and it seems to be climbing, and so we'll let that stabilize. Let's do the other channel. Ooh, is this thing damaged? No, it's okay. And 4.9, that's pretty good. I'm going to leave that alone. Okay, I'll let that sit for about 10 minutes and I'll see how it drifts, if it drifts at all. Yeah, that's still good. We're going to leave it at that. Okay, on to the biasing adjustments. Now if you look at the middle of your screen there's a connector here on the power amplifier board, and this is where you get your biasing measurements from. There's a 5-pin connector here. The center pin is ground, okay, and then these 2 on this side are across, I believe it's this emitter resistor, and then these 2 on this side are across this emitter resistor. Now you got to remember it's only across one resistor, not both. So we want to attach our probes to one or the other and set up our 0 point. So let's try that right now. See if we can get this without zapping myself or shorting something. I suppose there's a connector you could use to plug in there, and then you could bring the wires out. Okay, I think I got it. So they're looking for 10 to 14 millivolts. Oops. the hell? Stupid meter. They're looking for 10 to 14 millivolts, and I got 9.5. I'm happy with that. I'm going to leave that alone. And then I'll monitor that as the amp warms up, because it's only been on for about 10 minutes right now. Let's do the other channel. These are not the most convenient place for this. Of course, the camera's right in my way. Let me see if I can get this hooked on. Not the most convenient. Okay, I think I got it. So this one here is down around 6. So I'm going to... What the hell? Stupid buttons. Okay, I'm going to turn this one up. And to do that, I need to go... There is a adjustment down here that I can't see. Where is it? Oh, there it is. It's a big white one. Let's turn this one up a little bit. Turn it up to about 9.5 as well. I always like to adjust to the low end of the bias. It kind of helps conserve energy and keeps the heat down. When you keep the heat down, you keep the life longer. Okay, so we're consuming 35 watts. And it seems like it's hovering right around 35 at idle. I'm going to let this cook for a while, and I'm going to come back and check it again. Alright, so it's been on for about half an hour now, and it's actually gone down a little bit. And I'll readjust it, and it's pretty good. I think this side's a little warmer, maybe by a couple degrees, who knows. So I'll get this tuned up, and then we'll do a power test. Alright, so we're all wired in for a power test here. I got my load, the scope, watt meter, everything going here. Now I need to turn it on, set up my signal generator. Let's get this going. 1000 hertz tone to start, and let's turn it on and see what we can do with this thing. Set it up for auxiliary. There. Okay. It's auxiliary, tone going through. We should be able to see something on the screen. Yes, we do. Turn this thing up. We're clipping already. Let me rebalance my scope here. Okay. Ooh, here's clipping. So what are we at here? Let's try and get a good reading on this. Right about there, I think. Oh, and I don't even have a voltmeter hooked up. Shows how unprepared I am. Okay. Let's start our timer. And let me get a reading here. On the left channel. Now, are we at max? Yeah, we're there. I'll turn this down just a touch. And we are at 28.52 volts RMS on the output. So we'll let this cook for a while. And we'll see how it does. Full power, we're consuming 375 watts. So we're approaching the 5-minute mark here, and the heatsink is already up above 55 degrees Celsius, 56. and climbing. Kind of thinking this heatsink's a little undersized for what we got going here. A lot of heat coming off this. It's getting quite warm. So we might end this test a little early. We'll see. Okay, I'm shutting things down here because a problem with my heatsink here, my load. It's over 200 degrees Celsius, and the solder is melted on the connections here because it's just so much heat. But let's look at this. This is up around 60, 67, 68, almost 70 degrees on the main heatsink. Okay. Transistors around 70, 75 degrees, 77. So they're doing pretty good. A lot of heat on this board too. It was up around 70 degrees on this, on these these transistors here. This heat zone. So a lot of heat, yes, but it lived up to the reputation. So I'm gonna let this cool down, and we're gonna get some square waves and we'll see how it looks. Okay, one thing I want to check is from no load to full load regulation of the power supply. So no load, we got 115 volts. So let's turn this up and we'll see how much it sags. I don't have this set up properly here. First, let's turn this and this. Okay, let's turn this up to clipping one more time. Okay, we're down 97.3. 97.3 from 115. Alright, here's our square wave. 1000 hertz tone. Let's see. We can get to the controls here. Alright. Okay, here's tone control off and tone control on. The left channel has a little bit of a level discrepancy. So when I turn it on, the tone control's on, the level in the left channel drops a little bit. Okay. Bass cut, bass boost. Still a little bit of dirtiness there. I think that will fix itself with use. Treble cut. Ooh. Kind of harmonic there. Treble boost. That's odd. How often you see that? So let's center. Let's see here. Okay. Let's go up in frequency. 10 kilohertz. Oh, that looks pretty good for 10 kilohertz, I'd say. So let's keep going. We got 26 kilohertz. Kind of losing it right around here. 40 kilohertz square wave. That's actually pretty good. I'm impressed. That's what a nice fast rise time does. Let's check on the low end. Oh, what happened? Went into protect. Turn our signal off. There we go, we reset. Okay. Actually, what we're doing is putting DC in it. That's why it's shutting down, because I have it set for 0 hertz. And I screwed up here. I should have it at least, there we go, came back. So don't put DC in your amplifier. It doesn't like it. Okay, we're down 100 hertz. Let's go to 90. It's 40 hertz, 30, 20, 10. That is damn good square wave for 10 hertz. This is a good amplifier, I think. It's a keeper. Anyways, I think it's proven everything it needs to do, and it's working great. Now all we need to do is listen to it. You have the right, you're on the frequency. So there it is, it's done, and I really enjoyed working on this one. I think this is going to be a keeper. This is a nice amplifier. If too bad it's missing the door. That's my main beef with this one right now. But hey, what can you get for the money I paid for it? So it's a nice amp. It's got some problems. I think the heat sinking is a little bit inadequate, but that, you know what, that's such a minor thing. I wouldn't let you put you off on purchasing one of these. Not always do we operate our amplifiers at full power for 10 minutes, so I think it's fine. Another thing I didn't like about it is the silly lamp system they have on this. You know, it's when it works great, but I think it was a little bit overkill, and I think replacing the lamps with LEDs is a good call. Other than that, everything feels good about it. I think it's a good performer, and I'm going to enjoy listening to this one for the next little while. So the big story on this one was lamps mostly. We had all the dead lamps, and then we did replace some caps. Some of these are on the way out. I replaced one transistor. It's a 2SD313, and it has low gain, so I replaced it. It's in the regulated supply. Everything else was okay, you know, except for those few caps. And this thing doesn't have many caps in it. That's pretty much the entire amplifier, excluding the main filter caps, which they have 2 in parallel to make up for any losses. But it's a good machine. That's it for this one. So stay tuned. We got more stuff coming up next week, and I hope you tune in for that. So take care, and we'll talk to you next time.